Welcome to Statistics Made Simple. I am Savita Valsang, and here I have solved the second PUC, second model paper, hoping that it will be useful to most of you. Section A, first main, choose the most appropriate answer from the choices given. 5 into 1 is equal to 5. First question, the condition for the time reversal test is A. P01 into Q01 is equal to V01. B. P01 into P10 is equal to 1. C. P01 into P10 is equal to 0. And D. P01 into V01 is equal to Q01. The correct option is B. P01 into P10 is equal to 1. Second question, in a binomial distribution, if NP is equal to 2, the relation between mean and mode is A. Mean is greater than mode. B. Mean is less than mode. C. Mean is not equal to mode. And D. Mean is equal to mode. The correct option is D. Mean is equal to mode. So whenever NP is an integer, the mean and mode will be equal for the binomial distribution. Third question, the probability of rejecting the null hypothesis when it is actually true is called A. The size of the test, B. The power of a test, C. Type 1 error, D. Type 2 error. The correct option is A. Size of the test. Fourth question, in statistical quality control, if the standard is known, then the central line of the R chart is A. Sigma dash, B. D2 sigma dash, C. D1 sigma dash, and D. D2 sigma dash. The correct option is B. D2 sigma dash. Fifth main, the minimum of the column maximum is known as A strategy, B saddle point, C minimax, and D maximum. The correct answer is C minimax. Second main, fill in the blanks by choosing the appropriate answers given in the brackets. 5 into 1 is equal to 5. Sixth question, the life table gives the life history of a cohort as it gradually diminishes by deaths. Seventh question, the sudden unexpected variation in a time series, it is called as the irregular variations, or sometimes it's also called as the random fluctuations or erratic variations. Eighth one, if Z1 and Z2 are two standard normal variates, then the distribution of Z1, here there's a small mistake, it has to be Z1 square plus Z2 square will be chi-square with 2 degrees of freedom. Ninth question, a function of the sample values is called as a statistic. And the 10th question, a game is said to be fair if the value of the game is 0. Third main, match the following. 11th question, 5 into 1 is equal to 5. A. The capacity of a woman to bear children is fecundity. B. Base period, it should be economically stable. The T distribution curve, it is asymptotic to the x-axis. The likely value of the unknown parameter is called as an estimate. And the inventory model 2 is shortages are allowed. Fourth main, answer the following questions. 5 into 1 is equal to 5. So the 12th question is write the formula for estimating the population between census years. So the formula is given by PT equal to, it is P0 plus B minus D plus I minus E. So where P0 is the population in the census year, B, D, I and E are the number of births, deaths, immigrants and emigrants during the time period T. 13th question, mention one of the uses of index numbers. I've listed down all the 5. You can write any one of them. First one, index number simplifies the data, thus facilitates comparative study. Second, index numbers are used in studying trends and tendencies. They help in measuring purchasing power of money and also used for deflation. Then fourth, index numbers measure changes in cost of living of different groups of people. And fifth, index numbers are used by the government to frame suitable policies regarding fixation of bank rates, allowances to government employees, license to new firms, imports, exports, taxation, etc. 14th question, for what value of P binomial distribution is symmetric? So the binomial distribution is symmetric when P is equal to 0.5. 15th question, define null hypothesis. A hypothesis which is tested for possible rejection under the assumption that it is true is called the null hypothesis. Sixteenth question, when you say that a basic feasible solution of transportation problem is degenerate? So when the number of positive allocations, so positive allocations are usually denoted by Xij. If these are less than m plus n minus 1, where m stands for the number of rows and n stands for the number of columns, then we say that the transportation problem is degenerate. Section B, fifth main, answer any 5 of the following questions. 5 into 2 is equal to 10. 17th question, obtain the trend values by the method of semi-averages for the following time series. Different years are given and the corresponding values are given. So the first step is to write down the number of years given. So given n is equal to 7, which is odd, and in the semi-averages method we have to divide the data into exactly 2 equal parts. So we will leave out the middle year, that is 2021. Next we have to find out the trend values. So the trend values are nothing but the average of the 3 values in the first half of the data, and that is you have to add 30, 52, 44, and then we have to divide it by 3. Okay, so it is 126 divided by 3, and this is equal to 42. So now this 42, make sure you write it corresponding to the middle year of the first 3 years, that is corresponding to 2019. Similarly, for the second half of the data, we find out the trend value by finding out the average of the 3 values 40, 46 and 58. So that is 144, which is divided by 3. And so you get the answer as 43. So 42 and 43, these are the trend values. So make sure that 42 corresponds to the middle year of the first half, that is 2019, and 43 corresponds to the middle year of the second half, that is 2023. 18th question, write 2 assumptions of interpolation and extrapolation. First, there are no sudden jumps in the values of the dependent variable from one period to another. Second, there is a sort of uniformity in the rise and fall of the values of the dependent variable. Third, there will be no consecutive missing values in the series. Now, when you're writing these points, make sure that you mention dependent variable. So this is important. 19th question, write the Bernoulli distribution with parameter p equal to 3 by 5. So first write given p equal to 3 by 5. So convert it into decimals. This is 0.6. Next find out q, which is 1 minus p. So 1 minus 0.6 is equal to 0.4. Now to write the Bernoulli distribution, we have to form a table. The table will consist of two rows. You will have x and p of x. So we know that x takes the values 0 and 1 for the Bernoulli distribution, and when x takes the value 0, it denotes failure, and when x takes the value 1, it denotes success. So we know that the probability associated with failure is q. So q is equal to 0.4, and the probability associated with success is p. So p is equal to 0.6. So this table is called as the probability distribution of the Bernoulli distribution. So x takes a value 0 and 1, and the corresponding probabilities are 0.4 and 0.6. 20th question, if the parameter of the t distribution is 6, find the standard deviation. So we know that the parameter of the t distribution is denoted by n. So let us first write given n is equal to 6. So next write the formula for the standard deviation of the t distribution. So consider standard deviation of t is equal to, it is root of n divided by n minus 2, which is equal to root 6 divided by 6 minus 2, which is root of 6 divided by 4, and then on simplification you will get 1.23. 21st question, mention two branches of statistical inference. The first one is testing of hypothesis, and the second is estimation theory. Twenty-second question, write the chi-square test statistics with degrees of freedom in testing of independence of attributes in a 2 by 2 contingency table. So if you can't remember the formula, so remember that for the contingency table, we mark the cells as A, B, C, D, and we also form a total row and a total column. So here the total for the rows will be A plus B, then here you have C plus D, and then you have A plus C, and this is B plus D. So now let us write, and then you can draw the cross arrows from A to D and then B to C. So how do you remember the formula? The formula is chi-square equal to capital N into the product of the first cross diagonal, that is AD, minus the product of the second cross diagonal, which is BC, and don't forget to square, whole square divided by, it is the product of all the totals in the denominator. So take the first row total, that is A plus B, take the next row total, that is C plus D, into the first column total, that is A plus C, and the second column total, that is B plus D. So this follows chi-square with 1 degree of freedom. So this is the formula of the chi-square test statistic for independence of attributes in a 2 by 2 contingency table. 23rd question, mention two types of causes of variation in a manufacturing process. This question is from SQC. So the first cause of variations are the chance causes, and the second are the assignable causes of variation. 24th question, if R is equal to 100 units per month, C3 is rupees 100 and C1 is rupees 0.50 per unit per month, then find Q to the power 0. So now let us first write the formula for Q to the power 0, which is the economic order quantity. So the formula is, consider Q to the power 0 is equal to root 2R C3 divided by C1, which is equal to root 2 into 100 divided by 0.5. So on further simplification, you get Q to the power 0 is equal to 200 units. Section C. Sixth main, answer any four of the following questions. 4 into 5 is equal to 20. 25th question, calculate the consumer price index number by aggregative expenditure method for the following data. The commodities are given, then the quantities in 2019 is given, where 2019 is a base year. Then prices are given for 2019 and 2024, where 2024 is the current year. So first let us write the formula for the aggregative expenditure method. So I'll write, consider CPI, that is consumer price index, is equal to summation P1 Q0 divided by summation P0 Q0 into 100. So if you observe carefully, this is very similar to last year's price index number. Next, let us mark the columns in the table. So the quantity in 2019 will be marked as Q0. The price in 2019 is P0, and the price in the current year 2024 is marked as P1. So next let us form the columns P0 Q0 and P1 Q0. So next let us find out P0 Q0 values. So it is first 15 into 7, you will get 105. Next is 280, then we get 210, 400 and 630. Similarly, find out P1 Q0. So it is 15 into 9. So the first value is 135. Then you get 360. Then you get 170, 475 and 810. Let us now find the totals of both the columns. So summation P0 Q0 will be 1625 and summation P1 Q0 will be 1950. So next let us substitute in the formula to get the final answer. So this is equal to summation P1 Q0 is 1950 divided by 1625 into 100. So we get CPI is equal to 120. 26th question, interpolate and extrapolate the sales for the years 2021 and 2025 from the following data. The years are given from 2019 to 2025 and the corresponding sales in crores of rupees are given. So now the first step is to mark the year as X and the sales as Y, and then you mark Y0, Y1, Y2, Y3, Y4, Y5 and Y6. So to interpolate and extrapolate, we have to make use of the binomial expansion method for which we will also need the Pascal's triangle. So I've already written the Pascal's triangle at the side. So please make sure that you learn how to write the Pascal's triangle. I have also prepared a video which you can refer to. So now let us start the problem. So the first step is to write the number of known values of y. So write given number of known values of y. So we see that 5 values of y are given: 1, 2, 3, 4 and 5. So number of known values of y is 5. So that is, we write n is equal to 5. So this step is important. Next, write the formula. Consider y minus 1 to the power n is equal to 0, which implies y minus 1 to the power 5 is equal to 0. Now let us expand this equation. So which implies you start with y5, leave some space, then y4, then y3, y2, y1, y0, and then equate it to 0. So first we'll have the plus sign, then you put minus, plus, minus, plus, minus, that is alternatively. Then seeing the Pascal's triangle, for n equal to 5, the coefficients are 1, 5, 10, 10, 5 and 1. So here you write 1, then you have 5, then write 10, 10, 5 and 1. So 1 usually we don't write. Now seeing the table, substitute the values of y. So we get 50 minus 5 into 36 plus 10 into 30 minus 10 y2 plus 5 into 24 minus 20 is equal to 0. So expanding, you will get 50 minus 180 plus 300 minus 10 y2 plus 120 minus 20 equal to 0. Now leaving minus 10 y2, simplify all the remaining values. So you will get minus 10 y2 plus 270 is equal to 0. So which implies minus 10 y2 is equal to minus 270. Then minus and minus will get cancelled. So which implies y2 is equal to 270 divided by 10. So you get 27. So therefore the sales for 2021 is rupees 27 crores. To find the next missing value, you increase the suffix of y by 1 in this equation. So you'll get y6 minus 5y5 plus 10y4 minus 10y3 plus 5y2 minus y1 is equal to 0. So which implies y6 minus 5 into 50 plus 10 into 36 minus 10 into 30 plus 5 into 27 minus 24 is equal to 0. So which implies y6 minus 250 plus 360 minus 300 plus 135 minus 24 is equal to 0. So which implies y6. Now simplify the remaining values. So you'll get minus 79 is equal to 0, or y6 is equal to 79. So therefore the sales for 2025 is rupees 79 crores. 27th question. Fit a Poisson distribution to the following data and obtain the theoretical frequencies for the number of printing mistakes per page. So they have given us the number of printing mistakes along with the number of pages. So number of printing mistakes you mark it as X and number of pages you mark it as F. So let us start the problem. So we can first define capital X as number of printing mistakes. So now the parameter for the Poisson distribution is lambda, and the lambda value is not given to us. So the next step is to find out the mean of the given data, that is x bar. So first let us find out fx. So 0 into 61 is 0. Next is 21. Then you have 30, 9, 4 and more is taken as just 4. So 4 into 0 is 0. So we get summation fx as 60. Also find out capital N. So capital N is equal to 100. Now let us write the PMF of the Poisson distribution. So for that we need the value of lambda. So lambda is nothing but the mean of the given data. So let us write the steps like this. So first we will write, we know that x bar is equal to summation fx by capital N, that is 60 divided by 100, which is equal to 0.6. Now the important step is we know that lambda is equal to x bar, so it is equal to 0.6. So what we are doing here is lambda is the mean of the Poisson distribution and x bar is the mean of the given distribution. So you equate both of them and then you get lambda as 0.6. Now the next step is to write the PMF. So let us write the PMF. So PMF is P of x is equal to, open the flower bracket, it is e to the power minus lambda. So e to the power minus 0.6 lambda to the power x. So 0.6 to the power x divided by x factorial, and x takes values 0, 1, 2, so on, 0 otherwise. Now first put x as 0. So when we put x as 0, we get p of 0 is e to the power minus 0.6, 0.6 to the power 0 by 0 factorial. So e to the power minus 0.6 is 0.5488 into 1 divided by 1. So 0.5488. Similarly, put x as 1. So p of 1 is equal to e to the power minus 0.6, 0.6 to the power 1 by 1 factorial, that is 0.5488 into 0.6 divided by 1, which gives us 0.3293. Similarly, put x as 2. So P of 2 is equal to e to the power minus 0.6, 0.6 squared divided by 2 factorial, which is 0.5488 into 0.36 divided by 2. So 0.0988. Then when x is equal to 3, P of 3 is equal to e to the power minus 0.6, 0.6 cubed divided by 3 factorial, which is 0.5488 into 0.216. 3 factorial is 6. So on simplification you get 0.0198. So next we have to find out probability of 4 and more. So therefore probability of x greater than or equal to 4 is 1 minus p of 0 plus p of 1 plus p of 2 plus p of 3. So this on substitution and simplification gives us 1 minus 0.9967, which is equal to 0.0033. So now let us write all the probabilities which we found out in the given table. So next column you form here is P of x. So let's list down the probabilities. So 0.5488, 0.3293, 0.0988, 0.0198 and 0.0033. So next the question is to obtain the theoretical frequencies. So Tx is equal to capital N into P of x. So each of these probabilities we have to multiply with capital N, that is 100. So 0.5488 into 100 will give us 54.88. Then you will get 32.93. Then you will get 9.88. The next one is 1.98 and then you will get 0.03. Now usually the frequencies, they have to be whole numbers. So what we do is 54.88, we will take it as 55. 32.93 is taken as 33. 9.8 is taken as 10, 1.98 is taken as 2, 0.03 is taken as 0. So the final frequencies are 55, 33, 10, 2 and 0, and the total is 100. 28th question. There are 15 lecturers in a college. Out of them, 8 belong to the science faculty. The college management builds 5 residential quarters and allots them to 5 randomly selected lecturers. By using hypergeometric distribution, find the probability that first subdivision, all the quarters are allotted to science lecturers, and a second subdivision, 3 quarters are allotted to science lecturers. As they have already mentioned, it is the hypergeometric distribution. We need to find the 3 parameters n, a and b. So let us start the problem. Write given. So A will be the number of science lecturers, because the entire question is related to science lecturers. So A will be the number of science lecturers, which is 8, and they have mentioned that the total number of lecturers, so it is A plus B is equal to 15. So you find out B, that is 15 minus A, which is 15 minus 8, which is equal to 7. So 8 will be the number of science lecturers and 7 will be the number of non-science lecturers. And they have mentioned that 5 lecturers are randomly selected. So n is equal to 5. So this is what is given. Next, we have to define X. So X will be number of quarters allotted to science lecturers in a random sample of size n equal to 5. Then let us write the PMF. So PMF is P of X equal to, it is 8ACX, so it will be 8CX, BCN minus X, so 7C 5 minus X divided by A plus BCN, that is 15C5, and X takes values from 0, 1 to minimum of A comma N. So X is equal to 0, 1, 2, so on. It is minimum of 8, 5. So we see that the minimum value is 5. So we get P of X is equal to 8CX, 7C5 minus X divided by 3003, and X takes value 0, 1, 2, 3, 4, 5. Now let us start with the first subdivision. So first subdivision A should find the probability that all the quarters are allotted to science lecturers. So that means we should find out probability of capital X equal to 5, which is equal to P of 5. So substituting in the PMF, we will get 8C5, 7C5 minus 5 divided by 3003. So this is equal to 8C5 is 56, 7C0 will be 1 divided by 3003. So we get probability of X equal to 5 is 0.0187. Now let's move on to the next question. That is, we should find the probability that 3 quarters are allotted to science lecturers. So we have to find probability of X equal to 3, which is P of 3. So on substitution, we will get 8C3, 7C5 minus 3 divided by 3003. So 8C3 is 56 into 7C2, that is 21 divided by 3003. So we get 1176 divided by 3003. So the final answer is 0.3916. 29th question. A machine makes screws with diameter 0.3 inches. A random sample of 10 screws shows mean diameter 0.32 inches with a standard deviation of 0.15 inches. Test whether the machine is functioning properly at 5% level of significance. So now they have used the word mean, and then they have used the word standard deviation, and they have taken only one sample. So it is test for single mean. Next, you have to check the value of n. So because n is less than 30, it is t test for single mean. So let us start the problem. So remember that for the t test, the population standard deviation and the population variance will never be given. That is, sigma or sigma square will never be given for the t test. So let us start the problem. First write given. So now the first sentence, it doesn't have the word sample, so it means it is with respect to the population. So in other words, mu naught, that is the mean diameter of all screws, is given, that is 0.3. Then a random sample of 10 screws is taken, that means n is equal to 10, and the mean of the sample, that means x bar, that is 0.32, and the standard deviation of the sample, that is S, is 0.15, and they have also mentioned that the level of significance is 5%, that is alpha is equal to 0.5. So now we write H naught. So H naught will be mu is equal to 0.3 versus H1. Mu, because they have not used the words like more, less, above, increase, decrease, it will be a two-tailed alternative. Mu is not equal to 0.3. Then we write under H naught, the test statistic is so it is T equal to x bar minus mu naught divided by S by root of n minus 1, which follows Tn minus 1. So make sure that you write the formula completely so that you don't lose out on the marks. So now let us substitute. So you will get T is equal to 0.32 minus 0.3 divided by 0.15 divided by root of 10 minus 1. So we get T is equal to, it is 0.02 divided by 0.15 whole divided by root of 9. So this is 0.02 by 0.15, root of 9 is 3. So first do this calculation. Okay, so you will get 0.02 divided by 0.05, or you will get T is equal to 0.4. Now let us write the condition for a t-test for a two-tailed test. So at this side, let us write the condition. So the condition for a two-tailed test is modulus of t is greater than or equal to t alpha by 2. So if this condition is satisfied, we reject H naught. Otherwise, we will accept H naught. So therefore, you find out modulus of t. It is modulus of 0.4. So therefore, we get mod t is equal to 0.4. Next, write the degrees of freedom. So degrees of freedom is n minus 1. So it is 10 minus 1 is equal to 9. So now from the statistical tables, find out T alpha by 2. So at 5% level of significance for 9 degrees of freedom, we get T alpha by 2 is 2.26. Now the last step is the conclusion. So since modulus of t is equal to 0.4 is not greater than t alpha by 2 equal to 2.26 at 5% level of significance, for 9 degrees of freedom, we accept H naught and conclude that mu is equal to 0.3. And here alpha is equal to 0.05. 30th question. Find an initial basic feasible solution for the following transportation problem by northwest corner rule method and compute the total transportation cost. So 3 factories and 4 warehouses are given along with the supplies, that is the availabilities, and the demands, that is the requirements. I have rewritten the table and then I have marked the availabilities as A1, A2, A3 and the requirements as B1, B2, B3, B4. We see that summation AI is equal to summation Bj, which is 1400. So we say that the transportation problem is balanced. So in the northwest corner rule, we always start with the allocation in the northwest corner, that is x11 is minimum of a1 comma b1, which is minimum of 300 comma 75, and we get x11 is equal to 75. So we will write 75 in this cell. Next, check whether 75 is matching with the availability or is matching with the requirement. So we see that the requirement at P is satisfied. So whenever requirement is satisfied, we move to the right, that is the next cell, and then we have to make the allocation in this particular cell. So now let us continue the problem. So we have come to this cell now. So the second step will be, the cell is x1 2. So whenever requirement is satisfied, it will be x is equal to minimum of a minus x comma b. So x12 will be minimum of 1, you write it for a, and 2 you write it for b, and this x will be the previous allocation which you found, that is x11. So it is minimum of 300 minus 75 comma 325. So this is equal to minimum of, so it will be 225 comma 325. So we get x12 is equal to 225. Now let us write the allocation in the particular cell. So here we will write the value as 225. So 225 doesn't match with 300, 225 doesn't match with 325. But when you add 225 to 75 in this particular row, it gives you 300. So we see that availability is satisfied at A. So whenever availability is satisfied, we move vertically down. So we come to this particular cell, and then we have to make the allocation in that cell. So now the third step, let us write. So we have come to this cell is 2 2. So the formula is x22 is equal to, because availability is satisfied, it is minimum of, the formula is a comma b minus x. So 2, the subscript you write for a, the other 2 subscript you write it for b, and x will be the previous allocation, which is x12. So this is equal to minimum of a2 is 500 comma b2, that is 325 minus 225. So this is equal to minimum of 500 comma, so we get the value as 100. So x22 is equal to 100. So now let's write the allocation in the table. So here we will write 100. So now we see that 100 doesn't match with 500, 100 doesn't match with 325. But in this particular column, when we add 225 and 100, we get 325, which matches with the requirement at Q. So because the requirement is satisfied, we move to the right, and then we have to make the allocation here. So let us write the next step. So because a requirement was satisfied, the formula will be x is equal to, it is minimum of a minus x comma b. So we have come to this cell is 2 3. So x23 is equal to minimum of 2, you write the subscript for a, 3 you write it for b, and x is the previous allocation, that is x22. So you will get minimum of a2 is 500 minus 100 comma b3, that is 500. So it is minimum of 400 comma 500. So you get x23 is equal to 400. So again, let's write the allocation in that particular cell. So here you write 400. So now 400 doesn't match with 500, 400 doesn't match with this 500. But when you add 400 and 100, you get 500. which matches with the availability at B. So because the availability is satisfied, we move vertically down and then we come to this particular cell. So when we come to that cell, we have to write the next step. So the fifth step will be, we have come to this cell. So this cell is 3, 3. So x 3, 3 is equal to, because availability was satisfied, the formula now is a comma b minus x. So it will be a3 comma b3 minus the previous allocation, that is x23. So this is minimum of a3 is 600 comma 500 minus 400, which is equal to minimum of 600 comma 100. So we get x33 is equal to 100. So again, write the allocation in that corresponding cell. So here we will write 100. So 100 doesn't match with 600, 100 doesn't match with 500. But when you add 400 and 100 in this particular column, it matches with 500, which is a requirement at R. So now because the requirement is satisfied, you come to the cell here and we make the allocation, and that's where the problem ends. So now the sixth step, we have come to this particular cell. This cell is 3, 4. So x34 is equal to, because requirement was satisfied, the formula is minimum of a minus x comma b. So it is a3 and here you'll have b3, and the previous allocation is x33. So this is equal to minimum of a3 is 600 minus 100 comma 500. So this is minimum of 500 comma 500. So we get x34 is equal to 500. So the problem ends now because we have reached the last cell in the table. Let us write the allocation here. So you write 500. So now you can check whether all your allocations are correct. 75 plus 225, 300. 100 plus 400, 500. 100 plus 500, 600. Then 75 matches with 75, 225 and 100, 325. 400 plus 100, 500. And 500 matches with 500. So now let us write the last step. So you have to write the total transportation cost. So therefore, the total transportation cost is, so it is Z equal to 75 into 25 plus 225 into 17 plus 100 into 10 plus 400 into 18 plus 100 into 8 plus 500 into 13. So on complete simplification, you will get the final answer as rupees 21,200. 31st question. The purchase price of a machine is rupees 25,000. Its maintenance cost and resale value at different years are as follows. What would be the optimum replacement period for the machine? So this problem is based on replacement theory. So I've rewritten the table. So we have the years, the maintenance cost and the resale value. So let us start the problem. So first I will write what is given in the question. So you can write given capital P is equal to 25,000. Then let us write the formula. The average annual cost, so it is AN is equal to P minus SN plus summation CI divided by N. So N stands for the years, P is the purchase cost, and CIs are the maintenance cost. SN is the scrap value or the resale value. So let us do the markings in the table. So the maintenance cost is denoted by CI, the resale value is denoted by SN, and next we find out P minus SN according to the formula. So it is 25,000 minus 19,000 will give 6,000. Similarly, the next calculation will be 8,000. Then it is 10,000, 13,000 and 15,000. Next, we need to find out the cumulative maintenance cost, that is summation CI. So first write 600. Then it is 600 plus 1,300 is 1,900. 1,900 plus 2,020 will give 3,920. Then the next cumulative value is 6,920 and then 11,020. Then we will add both these columns, that is we'll find out P minus SN plus summation CI. So it's 6,000 plus 600 is 6,600. Then 9,900, 13,920, 19,920, and then we get 26,020. Now let us find out the annual average cost. So it is AN. So the formula is P minus SN plus summation CI divided by N. So the year column, let us mark it as N. So now it is 6,600 divided by 1 is 6,600. Then 9,900 divided by 2. So 4,950. Then 13,920 divided by 3. So 4,640. Then you get 4,980 and then it is 5,204. Next, what you have to do is you have to check the last column. You have to see where the annual average cost is decreasing and then immediately increases again. So it was 6,600, decreased to 4,950, further decreased to 4,640, and after this point it has increased to 4,980. So now let us write the conclusion, that is we have to find out what is the optimum replacement period for the machine. So write the conclusion. The machine should be replaced at the end of the third year and the minimum annual average cost is rupees 4,640. And it is always better to do the marking in the table also. So corresponding to 4,640, you can put an asterisk and you can also circle the year, which is 3. So in case you forget to write, the conclusion, then seeing what is marked in the table, you will get the entire 5 marks. 7th main, answer any two of the following questions. 2 into 5 is equal to 10. 32nd question, height of group of 1000 candidates who attended the army selection camp is normally distributed with mean 154 centimeters and standard deviation 3 centimeters. The minimum eligible height for army selection is 157 centimeters. How many candidates from above group are eligible? So it is mentioned that it is the normal distribution, and remember that the normal distribution is a sure question, that is the 32nd question is always the normal distribution. So the normal distribution has two parameters, that is mu and sigma, where mu is the mean and sigma is the standard deviation. So let us write given. So they have said the mean is 154, so mu is equal to 154 and the standard deviation sigma is equal to 3, and they have mentioned 1000 candidates are there, so capital N is equal to 1000. Next you define x, so x denotes the heights of candidates. So we write that is x follows normal, mu that is 154 comma 3 square. Then let us write the formula for the standard normal variate. So z is equal to x minus mu divided by sigma. This follows normal 0, 1. So please write this formula. You may get at least 1 mark for this. So let us start with the first question which is asked. They have mentioned that the minimum eligible height for army selection is 157 centimeters. So what it means that is a candidate should be 157 or he or she should be more than 157 centimeters for them to become eligible. So first we have to find out the probability of x greater than or equal to 157. So again I repeat, the minimum eligible height for army selection is 157, means a candidate should be 157 or should be more than 157. So as you know that the normal distribution tables is based on the standard normal distribution, we have to standardize this expression. So from x and 157 subtract mu and divide by sigma. So you'll get probability of x minus mu by sigma is greater than or equal to 157 minus mu divided by sigma. So this is equal to probability of x minus mu by sigma is z is greater than or equal to 157 minus 154 divided by 3. So this is equal to probability of z greater than or equal to. So on simplification, 157 minus 154 is 3. 3 by 3 will give us 1. So now let us continue. So we can draw the standard normal curve. This you can draw it at this side. So the center line is z equal to 0. The extremities are minus infinity and infinity. 1 is a positive value, so mark it on the right tail. So z is equal to 1. Here we have z is greater than or equal to 1. So it is shade to the right of the value. So shade from 1 to infinity. So continuing with this step. So this is equal to area from 1 to infinity. Then use the statistical tables and then find out the area from 1 to infinity. You will get it as 0.1587. Now be careful, they haven't asked you to find the probability, but they have asked you how many candidates from the above group are eligible. So whatever answer you have got, that probability, it should be multiplied with capital N to get the final answer. So you can write, therefore, the number of candidates who are eligible is 1000 into 0.1587. So this is capital N and this is P of X. So you will get 158.7. So approximately it is 159. 33rd question. In an institution, out of 200 students who took SSLC examination, 180 passed, and out of 300 students who took PUC examination, 240 passed. At 1% level of significance, can it be concluded that SSLC students have performed better than the PUC students? So observe that this particular question doesn't have the word mean, average, variance, standard deviation, and there are two samples, that is the SSLC students and the PU students. So this question is based on test for equality of proportion. So we should be able to get 4 values from the question. That is, usually we'll need N1, N2, and then you will need X1, X2, or you will need P1, P2. So remember that X1 and X2 will be whole numbers, whereas P1 and P2 are the proportions which will be given in terms of percentage, decimals, or fraction. So let us start the problem. We'll write given. So they have said in an institution, out of 200 students who took the SSLC examination, 180 passed. So N1 is equal to 200 and X1 is equal to 180. Similarly, out of 300 students who took the PUC examination, so N2 is equal to 300. 240 pass means X2 is equal to 240 and alpha is equal to 1%. So we can calculate P1. P1 is X1 divided by N1, that is the first sample proportion. So 180 divided by 200 is equal to, it is 0.9. Similarly, find out P2, which is X2 divided by N2, that is 240 divided by 300. This is equal to 0.8, which is the second sample proportion. Now let us write H0. H0 will be the two population proportions are equal. So P1 is equal to P2, then versus H1. Now they have used the word better in the question. So because they have used the word better, let's read the sentence again. SSLC students have performed better than PUC students. So it means that the proportion of SSLC students is greater than the performance proportion of the PU students. So going back, it will be a right tail test. The word better will be here, a right tail test. So versus H1, P1 is greater than P2. Then let us write the formula under H0. The test statistic is, so Z equal to P1 minus P2. So P1 and P2 here are the sample proportions, whereas capital P1 and capital P2 are the population proportions, divided by root. It is PQ into 1 by N1 plus 1 by N2, which follows normal 0, 1. Next, we have to calculate capital P. So capital P formula is X1 plus X2 divided by N1 plus N2. So this is 180 plus 240 divided by 200 plus 300. So on simplification, we get capital P as 0.84 and Q will be equal to 1 minus P. So 1 minus 0.84 is equal to 0.16. Now substitute all the terms in the formula. So Z is equal to 0.9 minus 0.8 into root PQ. So 0.84 into 0.16 into, it is 1 by 200 plus 1 by 300. So this is 0.1 divided by root. You'll get 0.1344 into 0.05 plus 0.003. So Z is equal to, I'll write the final calculation. I'll get 0.1 divided by 0.0166, or you will get Z is equal to 6.02. Here we have taken only two places after the decimal. So now let us write the condition for large sample test for a right tail test. So the condition you should check whether Z is greater than or equal to K alpha. Then we will reject H naught. So this is the condition which we have to use. So write at 1% level of significance, K alpha is equal to 2.33. So the conclusion is, since Z is equal to 6.02, it is greater than K alpha equal to 2.33 at 1% level of significance. We reject H naught. So when we reject H naught, it means that we are accepting H1. So we conclude that P1 is greater than P2. The 34th question. 10 samples, each of size 5, were inspected and number of defectives in each of them are as follows. So the sample numbers are given from 1 to 10 and the number of defectives for each of the samples are given. Obtain the control limits for the NP chart. So number of defectives or the NP chart means it is the D chart, that is the number of defectives chart. So number of defectives, we have to first mark it as D. So let's start the problem. Write given. So they've said 10 samples. So that means K is equal to 10, which stands for the number of samples. And each is of size 5, means N is equal to 5. Next, we will write the side heading as the D chart, which is also called as the NP chart. So this is a case when the process standards are unknown. So you can write case when the process standards are unknown. Then write the 3 sigma control limits are, so UCL is equal to NP bar plus 3 times root NP bar Q bar. UCL is equal to NP bar minus 3 times root of NP bar Q bar, and CL is equal to NP bar. So CL is the control line, UCL is the upper control limit, and LCL is the lower control limit. So you can also write where P bar is equal to summation D divided by NK. So therefore, you will get P bar is equal to, so add up summation D, that is all these defectives if you add, you will get the total as 16. So it is 16 divided by N into K, which is 5 into 10. So you get 0.3. And Q bar will be equal to 1 minus P bar, which is 1 minus 0.3, which is equal to 0.7. So therefore, we get UCL is equal to, it is 5 into 0.3 plus 3 times root of, it is 5 into 0.3 into 0.7. So on further simplification, we get this is equal to 1.5 plus 3 into root of 1.05, which is 1.5 plus 3 into 1.0247, and this is equal to 1.5 plus 3.0741, or UCL is 4.5741. And LCL is equal to 1 minus 3.0741, which is minus 1.5741. And because we have got LCL as negative, we cannot have negative number of defectives, so it is approximated to 0. So finally we get the control limits as CL is equal to 5 into 0.3, that is 1.5, UCL is 4.5741, and LCL is approximately equal to 0. 35th question, solve the following linear programming problem graphically. Maximize z equal to 2x plus 3y subject to the constraints x plus y greater than or equal to 350, 2x plus y less than or equal to 600, and x comma y is greater than or equal to 0. So step 1 is we convert inequalities to equalities. So it will be x plus y is equal to 350, and you will have 2x plus y is equal to 600. Step 2, to obtain the points of the two lines. So now you start with the first line. So consider x plus y is equal to 350. So first put x equal to 0. So you'll get y is equal to 350. And then you put y equal to 0. So you'll get x equal to 350. So 0 comma 350 and 350 comma 0 are the points of the first line. Now similarly, you take the second equation. So you consider 2x plus y is equal to 600. Then you put x equal to 0. So you will get y equal to 600. And when you put y equal to 0, you get 2x is equal to 600. So which implies that x is equal to 600 divided by 2, that is equal to 300. So the 2 points for this line are 0 comma 600 and 300 comma 0. So now the next step is to draw the graph. So step 3 is to draw the graph. So I have already drawn the graph on the graph sheet, and remember that in the exam an LPP problem should be drawn only on the graph sheet. And the 35th question is a sure question on LPP. So do practice it well so that you can score the full 5 marks. So now on the x-axis, I have taken the scale as 1 centimeter is equal to 50 units, and on the y-axis also I have taken 1 centimeter is equal to 50 units. So on the x-axis I have marked from 0 to 350, and on the y-axis I have marked from 0 to 600. So 350 is the largest x value and 600 is the largest y value. So let us draw the first line. So to draw the first line, we mark 0, 350. So this is 0, and so x is 0 and y is 350. So mark 0, 350 here. And the other point is 350, 0, that is x is 350 and y is 0, so that is this point over here. Then join 0, 350 and 350, 0 by a straight line, and on that line you write x plus y is equal to 350. Now move on to the next line. The 2 points are 0, 600. So x is 0 and y is 600. So here mark 0, 600. And the other point is 300, 0. So at this point x is 300 and y is 0. So mark this point as 300, 0. Then join 0, 600 and 300, 0 with a straight line, and on that line write the equation 2x plus y is equal to 600. And also don't forget to write the scale. X-axis 1 centimeter is 50 units and y-axis 1 centimeter is equal to 50 units. So now we move on to step 4. So step 4 is to obtain the feasible region. So to obtain the feasible region, what we do is we consider the inequalities which were given. So you take the first inequality, that is consider x plus y greater than or equal to 350. Now here you put both x equal to 0 and y equal to 0. So we get a 0 on the left hand side, and you have to check now whether 0 is greater than 350. So 0 is not greater than 350, so it is false. Similarly, you take the other inequality. So the other inequality is 2x plus y less than or equal to 600. So here again you put x equal to 0 and y equal to 0. So we get 0. And now 0, you have to check whether it is less than 600. So 0 is less than 600. So it is true. So now going back to the line x plus y equal to 350, that is this line over here. Because we have got false, how should you shade? You have to shade away from the origin, that means on top of the line. So for this line, that is x plus y equal to 350, because the condition which we have got is false, you shade on top of the line, that is away from the origin, which I have used black color. And for the next line, that is 2x plus y equal to 600, we have got the condition as true. So you have to shade towards the origin, that is below the line, and I have used red color. Okay, so now you have to check where you have both the types of shading. So remember that for a maximization problem, you should always get a closed figure. So closed figure can have 3 sides or it can have 4 sides. So in this case, this triangle here, it has the black color shading as well as the red line. And it is a closed figure. So mark this closed figure by the alphabets A, B and C. So now we move on to step 5. So what is step 5? So step 5 is to write the corner points of the feasible region. So if you observe carefully, the corner points of the feasible region are A. A is 0, 600. Next we have to find out B. So B, if you observe carefully, it is 0, 350. And then we have to find out C. So C, it is not possible to write it immediately. So what you have to do is where the two lines intersect, it is C. Now here at this point you have to drop a perpendicular to the x-axis. That will be the x value, that is 250, and from this point C you draw a line parallel to the x-axis such that it touches the y-axis, and this point, if you observe, it is 100. So C is 250, 100. Next we move on to step 6. So step 6 is to evaluate Z at the corner point. So now let us evaluate Z. So what is Z? It is 2x plus 3y. So now let us find out ZA. So ZA will be 2 into 0 plus 3 into 600. This is 1800. And ZB, it is 2 into 0 plus 3 into 350, which gives us 1050 on simplification. And ZC is equal to, it is 2 into 250 plus 3 into 100. So we get the answer as 800. Now because this is a maximization problem, among the Z values we should find out which is the maximum or the largest value. So the maximum value is 1800. So now let us write the final conclusion, as I don't have space over here and I wanted to finish it in this slide. I have written the conclusion in red color. So therefore the LPP has an optimal solution at, so you should write the point, that is A, 0, 600, and the maximum value of Z is 1800. Section D, the eighth main, answer any two of the following questions. 2 into 10 is equal to 20. 36 questions, subdivision A, compute the total fertility rate from the following data. This carries 5 marks. So the age groups are given in years, and then they have also given the female population and the live births for each of these age groups. So first let us write the formula for TFR, that is the total fertility rate, which is 5 times summation quinquennial ASFR. Quinquennial means the width of each of the age groups is 5, and ASFR is the age specific fertility rate, which is number of live births occurring to women in a specific age group divided by average population of women in the specific age group into 1000. So TFR formula will carry 1 mark and ASFR formula will carry 1 mark. So it is important that you write the formulae correctly. Next, let us do the calculation for ASFR. So form the column ASFR. So the first calculation is 500 divided by 2000 into 1000. Okay, so this will be equal to 25. Similarly, 1800 divided by 18,000 into 1000 will give 100. So for the next few age groups, you do the calculation for ASFR, which is the live births by the female population into 1000. So you get the next as 120, then 110, then you get 50, 29.4, and then you get 10. So next find out the total, that is summation ASFR. So the total for summation ASFR, you get it as 444.4. So the total is 444.4. Now let us substitute in the TFR formula. So therefore TFR is equal to 5 into summation quinquennial ASFR. So what is the total? It is 444.4. So we get TFR is equal to 2222 births per 1000 women. So this is the final answer. So TFR will carry 1 mark, the formula ASFR will carry 1 mark, and then ASFR calculations will carry another 2 marks, and the final answer for TFR will carry 1 mark. Subdivision B, calculate the standardized death rate for the following data. This carries 5 marks. So age group in years is given 0 to 20, 20 to 40, 40 to 60, 60 and above. The corresponding populations, deaths and the standard populations are given for these age groups. So STDR is nothing but the standardized death rate. So write the formula. Consider STDR is equal to summation PA divided by summation P. So here P stands for the standard population. So mark standard population column as P. So always mark the columns correctly so that you don't lose marks in the calculations. Then A stands for ASDR. So ASDR means age specific death rate. It is number of deaths occurring in a specific age group in a year divided by average population in a specific age group in a year into 1000. So STDR formula carries 1 mark and ASDR formula carries the other mark. So now in the table you form the column A. So what is A? A stands for ASDR. So it is simple to calculate. It is 80 divided by 8000 into 1000. So you will get 10. Similarly, 90 by 10,000 into 1000 will give 9. The next values are 15 and then you get 31. What else do we require? We require summation P also. So when you add up all the standard population values, you get summation P as 25,000. So this will carry 1 mark and the ASDR values will carry 1 mark. So next let us calculate PA. So form the column PA. So it is 7,000 into 10. So it will be 70,000. Then similarly 9,000 into 9 will be 81,000. Then 5,000 into 15 is 75,000 and 4,000 into 31 is 1,24,000. Next calculate summation PA. This will add up to 3,50,000. So now substituting the values in the STDR formula, we will get STDR is equal to 3,50,000 divided by 25,000. So cancel out 3 zeros in the numerator, 3 zeros in the denominator. So you will get 350 divided by 25. So the final value of STDR is equal to 14. So the final answer will carry 1 mark. The 37th question is usually based on index numbers. They can ask us to calculate 2 price index numbers or 2 quantity index numbers, or it can be time reversal test and factor reversal test. So here the 37th question is calculate Marshall, Edgeworth and Fisher's price index numbers from the following data. So it's important that you read the question carefully. They have asked us to calculate price index numbers. So the items are given, and 2019, the price and the quantity are given. So 2019 is the base year and 2024 is the current year. Its prices and quantities are given. So the price in the base year, you should mark it as P naught. The quantity, read the headings of the columns carefully. Don't assume that both will be prices, or here also both will be prices. Okay, here it is price and quantity. So the quantity in the base year, you mark it as Q naught. Then price in the current year, it is marked as P1, and the quantity in the current year, it is marked as Q1. So we have to form 4 columns. So the 4 columns which we need for Marshall-Edgeworth index number and Fisher's index number, you can form it in any order, but I'll form it as P naught Q naught. Then you have P1 Q1, then you have P1 Q naught, and then you have P naught Q1. These 4 columns will carry 4 marks, and make sure that the notations for P and Q are in lowercase. Don't use uppercase here. Okay, so let's find out P naught Q naught. So it is 10 into 12. So you get 120. Similarly, the next one is 210. Then you get 525, and then you get 540. The next column is P1 Q1. So P1 Q1 is 19 into 15. You get 285. The next value is 418. Then 703, and then 900. Next is P1 Q naught, that is 19 into 12. So we get 228, 330, 475, and 720. The last column is P naught Q1. So it is 10 into 15. So we get 150, then 266, 777, and 675. So make sure that you compute these columns correctly. So next, let us write the total. So summation P naught Q naught, we'll get it as 1395. Similarly, find out summation P1 Q1. This total is 2306. Then summation P1 Q naught. So summation P1 Q naught, the total is 1753, and a last column is summation P naught Q1, which is 1868. So here we'll get 4 marks for these calculations. Next, write the formula for Marshall-Edgeworth index number. So how do you remember Marshall-Edgeworth index number? So remember that any price index number, it will always start with summation P1 by summation P naught. So Marshall-Edgeworth index number is actually last payer's index number without the 100 and Paget's index number without the 100. So first write last payer's index number without the 100, that is summation P1 Q naught by summation P naught Q naught. Now put a plus in the numerator, plus in the denominator, and then you have summation P1 Q1 by summation P naught Q1. This is Paget's without the 100. So first write last payers, then write Paget's, put a plus in the numerator, plus in the denominator, and then write into 100. This will carry 1 mark. So now let us substitute the total. So when you substitute the totals, it is 1753 plus 2306 divided by 1395 plus 1868 into 100. So on further simplification, we get 4059 divided by 3263 into 100. So therefore we get P01 of ME, that is Marshall-Edgeworth index number, as 124.40. So you can take two places after the decimal for the final answer. So Marshall-Edgeworth index number formula carries 1 mark and the answer will carry 1 mark. Next we move on to Fisher's index number. So Fisher's index number, how do you remember the formula? So P01 of F is equal to root of, it is the product of Laspeyres and Paget's price index number, and outside the root you will have 100. So first draw the root. The first term over here is Laspeyres without the 100. So summation P1 Q0 by summation P0 Q0. And then the second term here is Paget's price index number, that is summation P1 Q1 by summation P0 Q1. Outside the bracket it is into 100. Okay, so remember to write the formula correctly. So it's important that you learn the formulae for all price and quantity index numbers. So let us do the substitution. So when you do the substitution, you will get root of 1753 divided by 1395 into 2306 divided by 1868, and outside the root you will have into 100. So this is equal to, when we divide, you take 4 places after the decimal after rounding off. So it's 1.2566 into 1.2345, and outside the root you will have into 100. So this is root of 1.5513 into 100, which is equal to, when you find the root, you will get 1.2455 into 100, or the final answer for Fisher's price index number is 124.55. So total calculations will carry 10 marks. 38th question. Fit a quadratic trend equation of the form y equal to a plus bx plus cx squared by the method of least squares to the following time series data. Estimate the value for 2024. So the years and the corresponding values are given. We'll mark years as x and value as y. And below the table, I'll first write given n, which is the number of years, which is 5, and 5 is an odd number. So among the years, you mark the middlemost year, that is 2021. So now let us first write the quadratic equation. Let y equal to a plus bx plus cx square be the quadratic equation. The three normal equations are na plus b summation x plus c summation x square is equal to summation y. Second, a summation x plus b summation x square plus c summation x cubed is equal to summation xy. Third, a summation x square plus b summation x cubed plus c summation x to the power 4 is equal to summation x square y. Now whenever n is odd, we calculate x as deviation from the middle year divided by h. So here the middle year is 2021 and h will be the difference between the years. So it is 1. So you get deviation from 2021. Now let us form the columns x, x square, x cubed, x4, x to the power 4, xy and x square y, and then we will obtain all the totals. So our aim always is to make summation x equal to 0. That's why we use the formula for x. So take the first year 2019. subtracted from 2021. And always be careful with the signs. So first you will get minus 2, then 2020 minus 2021 is minus 1, next is 0, 1 and 2. So you get summation x as 0. Now whenever you square a negative number, it becomes positive. So minus 2 square is 4, 1, 0, 1 and 4. So the total will be 10. X cubed. So whenever we find a cube of a negative number, it will remain as negative. So minus 8, minus 2 cube will be minus 8, minus 1, 0, 1 and 8. So when we add up this, summation x cube will be equal to 0. So observe that for the quadratic equation, when we find out summation x and summation x cube, both will be 0. Now when we find out x to the power 4 of a negative number, it becomes positive. So minus 2 to the power 4 will be 16. Then you'll have 1, 0, 1 and 16. So the total will be 34. Next we'll find out xy. So minus 2 into 40 is minus 80. Then you'll have minus 20, 0, 15 and 50. So the total will be minus 35. Next we'll find out x square y. So 40 into 4, 160. Then you have 20, 0, 15 and 100. So the total will be 295. So now let us substitute all these totals in the three normal equations. So let us take the first normal equation. So substituting, we will get 5a plus b into 0 plus c into 10 is equal to, I haven't found out summation y, so let's go back and find out summation y. So summation y total will be 130. Okay, so I'll go back to the second normal equation and substitute the values. So let me complete this. This will be equal to 130. Then the second normal equation is a into 0 plus b into 10 plus c into 0 is equal to minus 35. And a third normal equation is a into 10 plus b into 0 plus c into 34 is equal to, summation x square y is 295. So from the first normal equation, we get 5a plus 10c is equal to 130. From the second normal equation, we get 10b is equal to minus 35. So which implies b is equal to minus 35 divided by 10. So therefore b is equal to minus 3.5. Then from the third normal equation, we get 10a plus 34c is equal to 295. So now let us solve equations 1 and 3 simultaneously. So solving equations 1 and 3 simultaneously. So write both the equations one below the other. So 5a plus 10c is equal to 130, and then 10a plus 34c is equal to 295. So now we have to make the coefficients of either a or c the same. So in this equation, the coefficient of a is 5, and in the second equation, the coefficient of a is 10. So what we'll do is we will multiply the first equation by 2 so that the coefficient of a also becomes 10, and then we can subtract both the equations. So multiplying the first equation here by 2, we get 10a plus 20c is equal to 260, and the second equation will be 10a plus 34c is equal to 295. Now we have to subtract both the equations, so you can change the sign throughout. So 10a minus 10a will be 0, and then you have 20c minus 34c, it will be minus 14c is equal to minus 35. Then the minus signs will get cancelled on both the sides, so which implies 14c is equal to 35, or c is equal to 35 divided by 14. So therefore you get c is equal to 2.5. So now we can substitute for c in any one of the equations. So we will consider 5a plus 10c is equal to 130. So which implies 5a plus 10 into 2.5 is equal to 130. So which implies 5a plus 25 is equal to 130, or 5a is equal to 130 minus 25. So which implies 5a is equal to 105, or a is equal to 105 divided by 5. So you get 21. So therefore a is equal to 21. Therefore the fitted quadratic trend equation is yc equal to, so substitute for a, b and c in the quadratic equation. So we'll get yc is equal to 21, that is a, plus b summation, that is a plus bx plus cx square. So we'll get yc is equal to 21 minus 3.5x plus 2.5x square. So this is the fitted quadratic trend equation. Now they have asked us to find out the estimate for 2024. So estimate for 2024 can be found by making use of the fitted quadratic trend equation. So when x is equal to, so if you go back to the table, you can observe that for 2022 the x value is 1, for 2023 the x value will be 2, and for 2023 the x value will be 3. So when x is equal to 3, so y 2024 will be equal to 21 minus 3.5 into 3 plus 2.5 into 3 square. So this is equal to 21 minus 10.5 plus 2.5 into 9 will give 22.5. So the final estimate for 2024 is 33. Thank you all for watching, and I'm really sure that this video on the model paper 2 in statistics will be helpful to all students who are going to write the second PUC final examinations shortly.